So, most of these talks will begin with a show of hands of people who practice or have practiced Taekwondo or another martial art, and then discussing what martial arts they have practiced, how they practice, how long they practiced. But tonight I'll not do that. Tonight I'll talk about just one, and that'll be Taekwondo. I'll do that for two reasons. Reason one being, I practice Taekwondo, so I'm reasonably confident in speaking about it, but reasonably meaning not too high. I was originally going to start this by trying to break a board here on stage, before realizing that breaking that board in front of people is about as likely as me winning the lotto. That was funnier last week before somebody won the lotto, but whatever. Right. Reason two, though, is Taekwondo teaches what's known as the theory of power. In that, they deal with speed. In the little passage on speed, we have a formula. You might have known this formula before. It's E equals half mv squared. This is interesting for two reasons. First, this is the formula for obtaining kinetic energy of a moving object. Secondly, that formula tells us which of the two components of this formula is more important, that being velocity. To prove this, I've plugged in values before for variables of m and v, which are mass and velocity. I've plugged in 75 kilograms for mass and 5.1 meters squared for velocity, with the result being 975.375 joules. These numbers are somewhat realistic in that 75 kilos is my weight, so obviously it's a Taekwondo practitioner, and number two is 5.1 meters per second is an average taken from a biomechanics paper on the sidekick in Taekwondo. To test what I just said about velocity being more important, let's reset the values and plug in something different. Let's plug in 95 kilograms and 5.1 meters per second, which will give us 1,235.475 joules. And then let's reset that, stick with 75 kilograms, and add 1 meter per second to the velocity, which will give us a result of 1,375.375 joules. Now, why have I chosen these numbers? I've chosen these numbers because they both represent roughly a 20% increase in either coefficient. So the results show us that while having a 20% increase in either, the resulting kinetic energy will be different, with velocity increasing kinetic energy beyond what mass can increase it by. In the same vein, if you can think of bullets, say, take a 45 ACP bullet, which itself weighs more than a 5.56 NATO bullet, both are being used by military and police across the world. If they were both fired into ballistic jelly, roughly the shape, consistency, and size of a human being at 110 meters, the 45 ACP bullet is likely to stay in the jelly, whereas the 5.56 will more than likely penetrate it. And that is because there is more gunpowder propelling the 5.56 NATO bullet, meaning that it gets more muzzle velocity. So, in short, what I wanted to say is that in the battle of mass versus velocity, velocity will win. And with this, I've exhausted my breadth of knowledge in physics, so thank you and good night.